Welcome back, guys. In this lesson, we're going to be looking at part B of solving triangle problems. In the previous video, we looked at a number of word problems and practiced how we might draw those diagrams. We also looked at some diagrams and talked about ways that I could ask you some questions. Now we're going to actually get into the solving of those same problems. All right, so before we get into solving problems, I just want to go back through and do a real quick refresher on everything we've learned so far. First of all, when we're working with our calculator, it's important that your calculator is always, always, always in degree mode. And so you're going to check that by going into your calculator, clicking on the mode button, and making sure that degree is highlighted, so degree to the right there. As well, we use the mnemonic device SOHCAHTOA. Sometimes we write it as S, capital S, O, H, capital C, A, H, and capital T, O, A, just because our angles are written with capitals and our sides are written with small letters. But ultimately, this means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Sometimes it's important for us to remember that the angles in a triangle add up to 180 degrees. Sometimes we can just do some subtracting to find the remaining unknowns. We use Pythagorean quite a bit when we're doing triangle problems. So a squared plus b squared equals c squared. If you remember in our first lesson, I actually went through a shortcut that we can use so we could rearrange it to say, for example, c is the square root of a squared plus b squared, or a is the square root of c squared minus b squared, and so on. When we're solving for any kind of unknown side or unknown angle, the first thing we have to do is sketch a diagram. Now, if the diagram's already sketched for you, you're good. You don't have to you don't have to do that step. Now, depending on where your angle is, you're going to have to label your triangle. So you're going to label opposite, adjacent, and hypotenuse. And then using the information you have, you're going to choose the right ratio. So essentially, you're going to set up your ratio. So depending on what information you have, you'll choose either sine, cos, or tangent. And then you're ultimately going to set up your ratio and solve. So the shorthand of what's all written here is draw a diagram, label your triangle, set up your ratio, and solve. And our ratios are given to us here. You do have these on your formula sheet. Sine of the angle is opposite over hypotenuse. Cosine of the angle is adjacent over hypotenuse, and tangent of the angle is opposite over adjacent. Now, I do have these little nutshells here, and some of you might have been wondering what they are. Essentially, these are just a pictorial version of an equation triangle. I don't like to focus on them too much because I really want you to understand the algebra behind them. But if you were totally stuck and you needed some help with algebra triangles, we could cover up the one that we're looking for. So let's say cover up opposite, and it would tell us to go sine of the angle times the hypotenuse. If I was looking for cosine of the angle, that's adjacent over hypotenuse. Or if I was looking for adjacent, it would be opposite divided by tangent of the angle. Again, I don't really like to focus on those because ultimately I want you to know the algebra behind them. But they are there if you need them as a tool to start off with. All right, so let's take a look at our first question here. So we have the question asking us, how tall is the cliff? So we already have the diagram drawn for us, so we don't have to do anything there. Our first step is going to be to label our triangle. So we have 30 degrees. Looking across the triangle, opposite is the height, and adjacent is the distance from the cliff. Now, I don't need to label the hypotenuse because it's not playing any role in my question here. So opposite and adjacent, if I go back up to my questions here, actually I'll just write SOHCAHTOA. If I have SOHCAHTOA and I have opposite and adjacent, that means I'm going to use tangent. So using my formula here, tangent of the angle, which is 30 degrees, tangent of 30 degrees is opposite over adjacent. Now, to solve this question here, I'm going to have to multiply by 500 on both sides. And so that would give me 500, or h equals 500 times tan 30. And if you remember from the previous video, I said that I always put the number in front when I'm doing it in my calculator so that I avoid any issues if I forget a bracket. So 500 times tan 30 gives me 288.7 feet. So 288.7 feet. Again, for lengths, we round to the nearest tenth, and for angles, we're going to round to the nearest degree. All right, so I want you to pause the video and try one of these examples in the notes that you have. All right, so for the first question here, you would have had tan 58 equals b over 5.3 because b was our opposite and this was our adjacent. Because our numbers on the bottom were multiplying, so b is going to be 5.3 times tan 58. And that would give me 8.5 meters. If you had chosen to do option 2, you would have again had opposite and adjacent, and you would have written tan of 50 degrees is opposite over adjacent. B is 5 times tan 50, and that gives us 6.0 meters. Now, if you had written 5.9, remember that on your calculator it's going to show 5.959. And if I want to round to the nearest tenth, then I start with this number right here. I look behind it, there's a 5. The 5 is going to round this up to 0, which is going to round this up to a 6. So that's how we're getting 6.0 meters. All right, moving on, we're going to look at the same examples that we did our diagrams for in the previous video, but now we're actually going to go through and solve. So I'm going to go through the diagrams fairly quickly because we've already looked at that in the previous video. So the question here says a ladder is placed against a wall, forming an angle of 63 degrees with the ground. If the foot of the ladder is 3.7 feet away from the wall, how long is the ladder? So we start off by drawing our diagram. You may have that already drawn from your previous lesson. We've got 63 degrees. We've got our 90 degrees. We know that the distance from the wall is 3.7 feet, and we're looking for the length of the ladder. Sometimes people will put their X in the wrong spot, but you have to ask yourself which one represents the ladder, and that's our angle. Our next step after we have our diagram drawn is to label our triangle. So we have adjacent and we have hypotenuse. So looking at adjacent and hypotenuse, that is going to be cosine. So cosine of the angle, so cosine of 63 degrees. Notice I'm not writing the formula. I don't expect to see the formula. I do expect to see that the substitution is there. But cosine of 63 degrees is adjacent, which is 3.7, over hypotenuse. That being said, if you want to write the formula, there's absolutely nothing wrong with that. Now, going back to what we did in our very first lesson, we know that the numbers on top we're dividing. So 3.7 divided by cos of 63. So x is going to be 3.7 divided by cos of 63. So putting that into our calculator, we have 3.7 divided by cosine of 63 gives us 8.1 feet, or sorry, let me check that again. 8.1499, so 8.1 feet. All right, now the next question we saw in our previous video said that a tree casts a shadow that is 13.5 meters long and the angle of elevation to the sun is 43 degrees. The question is, how tall is the tree? All right, so we have our tree here and it's casting a shadow. Remember, the shadow is on the ground and it's forming an angle of elevation of 43 degrees. So angle of elevation comes from the ground towards the sun. So looking up from the horizontal, our shadow is 13.5 meters long, and the height of the tree is our unknown, is our x. So again, once our diagram is drawn, we label our triangle. So x is opposite, 13.5 is adjacent, and so our formula is going to be tan. So tan of the angle, so tan of 43 degrees is opposite over adjacent, which is 13.5. And again, numbers on the bottom, so we're going to multiply. So 13.5 times tan 43 gives us 12.6 meters. And again, if you want to check that with your calculator, you're going 13.5 tan 43, and we get 12.58895 and so on, so rounds to 12.6 meters. All right. Now, in our previous video, we had a question where I'd given you the diagram and you had to come up with the word problem. So this was the example where I told you that a surveyor was setting up a survey post directly across the river, and from a landmark, and then he heads downstream for a distance of 400 meters, and he takes a sighting on the tree from downstream. That sighting angle is 31 degrees. So he starts with his post, he walks down 400 meters, he sets up another post, and the angle to across to the river is 31 degrees. And we want to use that information to find the width of the river. So again, we start off by labeling our triangle. This is opposite and adjacent. And so again, opposite and adjacent means tangent. Now, just because you're seeing tangent a fair bit in here doesn't mean you're always going to see just tangent. Definitely when you get into our double triangle problems, we do see that tan shows up quite a bit, but ultimately you're just labeling your triangle and then using the ratio that comes of it. So we've got tan 31 equals x over 400. So solving, we're going to have 400 times tan 31. So 400 times tan 31 would give us 240.3 meters. So 400 times tan 31 gives us 240.3 meters. Now, if we were doing this in class, I would ask you to pick two questions, any two questions, and go through and solve. And with the video here, I'm just going through all the examples. So whichever ones you chose to do on your own, these are just the process for each one. So number 4, it says a plane is climbing at an angle of 12 degrees for 6.2 kilometers. How far does the plane travel horizontally? So we had our plane climbing for 6.2 kilometers at an angle of 12 degrees. So the angle of 12 degrees is right here, so an angle of elevation. The plane is climbing for 6.2 kilometers, so that would be the distance that it's traveling diagonally. And the question is, how far has the plane traveled horizontally? So there's our x value, and we label our 90 degrees. So labeling our triangle, this will be adjacent and hypotenuse. And adjacent and hypotenuse is cosine. So cosine of 12 degrees is x over 6.2. Solving here, it's going to be x is 6.2 times cos of 12 degrees. And plugging that into your calculator, you're going to get 6.1 kilometers. All right, now the last question here, it says, given the dimensions in the diagram, what is the pitch of the roof? And it says, note pitch is the same as slope. And if you remember, slope is rise over run. Now, knowing that slope is rise over run, that means we need to find the rise of the roof. So labeling our triangle here, we have opposite and adjacent. And so opposite and adjacent would mean we're using tan. So tan of 43 degrees is opposite over adjacent. Solving our problem, we would have 12 times tan 43. And 12 times tan 43 is 11.2 feet. Now, we want to keep that answer exact when we're actually calculating on our calculator. So we start off with the 12 times tan 43. And that gives us 11.19018. So I'm rounding it to 11.2 on paper, but we still have one more step to go, and that's to find our slope. And so if you remember, slope is rise over run. So our slope, or our pitch, is going to be our rise of 11.2 divided by our run of 12. Now, I've again have it rounded as 11.2 on paper, but on my calculator, I'm going to keep it exact. So I'm just going to hit the divide button, divide by 12, gives me 0.93. So 0.93 is my pitch, and the pitch doesn't have any units. All right, so let's take a look at some examples that relate to angles. So the first example here, it says, south-facing solar panels on a roof work best when the angle of inclination of the roof, in other words, the angle between the roof and the horizontal, is approximately equal to the latitude of the house. So for example, the latitude of Fort Smith, Northwest Territories is 60 degrees. So in order for these solar panels to be appropriate, the angle of elevation would have to also be 60 degrees. So the question is to determine whether or not this design for a solar panel is the best for Fort Smith. And so we're going to take a look at that. So here's our angle. I'm going to redraw the triangle down here. We have 9 and 12, and we're looking for that angle. And so ultimately we want to know, is the angle close to 60 degrees? Now you may already kind of predicted the answer, whether it's yes or no, but we want to be able to show work to justify our answer. So justify our answer means show work to support. And so we start off by labeling our triangle. So this is opposite and adjacent. Again, that's tangent. And we're looking for the angle. So tan of the angle equals opposite over adjacent, so 9 over 12. And remember that whenever we're looking for an angle, we use the inverse. So tan -1 of 9 over 12. And so our angle rounded to the nearest degree is 37 degrees. Now, ultimately, when you're doing your questions, I want to see at the bare minimum this for your work. So 37 degrees, is that close to 60 degrees? Not at all. So no, these solar panels or this solar panel design would not be appropriate for Fort Smith. All right, so I want you to choose one of the example problems here and try it on your own and then come back and check your answers. All right, if you picked option number 1, labeling your triangle, you'd have opposite and hypotenuse. So opposite and hypotenuse would be sine. So again, knowing that we're doing the inverse for angles, the angle would be sine -1 or the inverse sine of 5.25 all over 10.5. And so on our calculator, that would look like second function sine 5.25 divided by 10.5. And that gives us 30 degrees. If you had chosen option B, this would be adjacent and hypotenuse. So we're looking at cosine. So theta would be cosine -1 of 5 over 6.25. And so this would give us second cos of 5 over 6.25, which is 37 degrees rounded to the nearest degree. All right, so there's some practice questions we're going to go through. If you want to do these on your own, first pick any 2 questions that you like and do them, but I'm going to go through all of those questions here. All right, so first question, it says you have a rectangular piece of sheet metal that measures 8 feet by 4 feet from which you need to cut 2 equal right triangles. What angle from the horizontal will you need to measure to make the cut? So if you remember in the last video, it depends on which way you orient your sheet metal. I chose to orient it with the 8 feet on this side and the 4 feet on this side. If you turn your rectangle, that will just change your final answer, and we'll talk about that at the end. So if we have 8 and 4, the angle from the horizontal would be here. And it doesn't matter which side I put the 4 on because it's still going to be the same measurement. So ultimately, I have a triangle that looks like this. I have an 8 and a 4, and I'm looking for the angle. So labeling my triangle, this is opposite and adjacent. So to solve the question, I'm going to have my angle being tan -1 of 4 over 8. And so that gives me 27 degrees. Again, remember that we only use the inverse for solving for angles. Now, if you had oriented your diagram the other way, if you'd oriented your diagram the other way, we would have had an 8 here and a 4 here. This would have been our angle. We would have gone tan -1 of 8 over 4, and that would have given us 63 degrees. And if you notice, 63 degrees and 27 degrees add up to 90 degrees. All right, let's continue on with some examples here. So the next one says that the distance from home plate to the pitcher's mound is 60 feet 6 inches, or another way to write that is 60.5 feet or 60.5 feet. And the distance from the home plate to the first base is 90 feet. At what angle from the pitcher's mound would a player need to run to get onto first base? So we're looking for this angle right here. So labeling our triangle, this is adjacent and this is hypotenuse. And we're looking for the angle in between. Adjacent and a hypotenuse is cosine. So the angle is going to be cosine -1 of 60.5 feet divided by 90. Notice I had to convert my inches to feet because everything needs to be in the same units. And so cosine -1 of 60.5 over 90, if I put that into my calculator, it's going to be second cos of 60.5 divided by 90. gives me 48 degrees. All right. Next example, we have a downhill skier coming down a steep slope. If this section of the 1,420-meter ski slope has a vertical drop of 950 meters, what is the angle of elevation of the slope? So we're looking up here, labeling our triangle. This is opposite and hypotenuse. So opposite and hypotenuse is sine. So theta is sine -1 of opposite over hypotenuse. And so theta is going to be 42 degrees. All right, one more question here. You're on a hot air balloon that is floating 500 meters above Eagle Butte High School. At what angle of depression would you be looking if you were looking at a point on the ground that is 800 meters horizontally from the balloon? So we start off with our very fancy balloon because I'm a super awesome artist. Not so much. Drawing is not what I'm expecting. I'm not expecting masterpiece drawings. I just want to be a nice, simple diagram with all of your important information labeled. But our balloon is flying 500 meters above the ground, and it's looking at a point. It's looking at a point that is 800 meters horizontally from that height above the ground. So 800 meters is down here. 500 meters is our height above the ground, and we're looking down at that point. Now, the question says that we're looking down at an angle of depression of, it's asking for what is that angle of depression. So the angle of depression is looking down from the horizontal. Now, calculating this out, I can either draw a diagram that looks like this with my 500 and my 800 and my angle of depression. I can also calculate the angle of elevation, which would give me the same answer, so 800 and 500. Ultimately, it does not matter which one I use because my opposite is still 500 and my adjacent is still 800. So labeling my triangle here, I have opposite being 500 and adjacent being 800. Or if I look here, opposite and adjacent. So looking at this here, I'm going to be using tangent. So my angle is going to be tan -1 of 500 over 800. And so my angle is going to be 32 degrees. All right, so that gives you a large number of examples. I know that a lot of these involve tan, but it doesn't matter what your diagram is. Based on your diagram, whatever your labels are, that's going to tell you whether you use sine, cosine, or tangent. If you're looking for an angle, we always use the inverse. If the number is on top, so for example, if I had sine of, I don't know, 42 equals x over 5. So if my number's on the bottom, I'm going to multiply. If I have sine of 42 is 5 over x, then I'm going to divide. So again, inverse for angles, we only use those tan -1, sine -1, and cos -1 for angles. If we're looking for the side length, in our ratio, our numbers on the bottom, we're going to multiply. Our numbers on the top, we're going to divide. Those are all of the basics. Go and try some practice questions, and I'll see you soon.